I think there's multiple approaches to this, especially later on when it starts involving more joined up things. I've been watching chat and I've seen a couple of reasons come in as to why at least one of them's lying and one of them must be telling the truth. The one I spotted was that Bob and Diane contradict each other. Can't both be telling the truth. But something that people in chat have pointed out is that Alice and, you could also write Alice and Bob can't both be telling the truth because only one person broke the vase. Okay, so different approaches that you could use. Okay, so one of them has to be lying, and then I'd write something pretty similar, I think, to explain why one of them must be telling the truth. If you wanted to be really systematic about it, you could write out like, well, there are some possibilities of who broke the vase, and in each of these cases, someone's lying and someone's telling the truth. More about that in a moment, I think. Right, okay. Someone's lying, someone's telling the truth. Let's move on to the next part of the question. Okay. It feels a bit like, when you first see it, it feels a bit like there's 4 possibilities because exactly one of the 4 people is lying. But remember, from the previous part, we saw that Bob and Diane contradict each other. We also saw that Alice and Bob contradict each other. So I think that means that one of Alice and Bob is lying, or you could, if you, depending on what you wrote for the previous part, you might spot that one of Bob or Diane is lying, because that was your argument before for why exactly why at least one of them was lying. I would say one of those telling the truth. Okay, so one strategy is to think about cases for who is lying. That's one possibility. So we can think about, is Alice lying, and then think about whether that makes sense or not. We can think of, is Bob lying? Yeah, that makes sense. Bob. Is Charlie lying? It doesn't really work. Or is Diane lying? Oh, actually, there are only a couple of cases if you think back to the previous part of the question. There's an alternative approach, which I've seen someone in chat mention, which I like, which is to think about cases for who broke the vase. So back in the original setup, there were only 4 possibilities about who the culprit could be. So we could work through those possibilities and say, well, for each of these cases, if Alice broke the vase, who's telling the truth and who's lying? If Bob broke the vase, who's telling the truth and who's lying? Charlie and Diane go through the same process to try and work out a kind of scenario statement lie matrix kind of thing, which could be good. Okay, part 3. Bob did it and is lying. A really succinct argument someone's just put in chat that I love is Bob is contradicting 2 people while the rest are contradicting 1 person or no one. I think that's a great way of looking at it. A great way of looking at it that gives you a different way of doing that argument. I think all of this is sort of equivalent, but that's good. Right. Okay, part 4. Grace has just told me Diane's telling the truth and Charlie broke the vase. Okay, and that seems to agree with Charlie and Diane is telling the truth. I'm going to write that on the screen so that we've got it there. Diane, Charlie. Let's talk about how we got there. Average has said we could draw some sort of table, which is what I did when I first saw this. So I'm going to try and draw that table. Here's how the table works. The table works like you think about A, B, C, and D for who broke vase, and then you look at their statements A, B, C, D, and in each case you go down and you say, are these statements true or false? So if Alice broke the vase, then Bob would be. If Alice broke the vase, then Alice would be lying, So this would be false. F for false. Bob would be lying pointlessly. Charlie would be telling the truth. It was Alice. And Diane would be telling the truth. Diane disagrees with Bob. If Bob broke the vase, then our table would say, well, Alice is telling the truth in this case. Actually, only this case. Only if Bob broke the vase is Alice's statement true. Bob's statement, well, hang on, Bob's statement's only true if Diane broke the vase. Charlie's statement is true unless Charlie broke the vase, and Diane's statement, oh, well, Diane just disagrees with Bob, so it's this. Okay, so I quite like this table. If you do it and concentrate all the way through and then remember how to count, you can count how many false things there are in each column to say, well, look at all the possible cases. Other arguments people have put in chat look pretty good as well. So again, you could work through the cases of checking which person is the one telling the truth. And again, Bob and Diane disagree, so it's going to be one of them. Oh no, could they be both wrong? No, they can't be both wrong. Right, cool. Part 5. What if 2 of the statements are true and 2 of them are false? So if you're playing along with the table, you'll see that you are either in this case or you're in this case. And then you can read off from your table that either Alice or Diane broke the vase. Here, I think, really, the only way into here is going to be to check the possibilities, to say, list the people who might have broken the vase. I think we're going to have to think about all of them. Except, I suppose we don't have to think about Bob and Charlie, because we've already shown that if Bob or Charlie broke the vase, exactly 1 or exactly 3 people were telling the truth. So again, we've only really got two cases. Yeah, so I think my explanation for this, someone said their explanation is very lengthy, sad face. My explanation for this is, right, okay, we've seen Bob and Charlie. Bob and Charlie can't be the answers for part 5 because they were already answers for parts 3 or 4. And these things are mutually exclusive. So we've only got to check Alice and Diane. I'm going to think about what happens. Is that consistent? If Alice broke the vase, is it exactly 2 and exactly 2? If Diane broke the vase, exactly 2 and exactly 2. Okay. Now we're done. Also, part 6 says, hence show if we don't know how many of the 4 statements are true, which is pretty normal. We don't know how many of these statements are true. Any one of the 4 could have broken the vase. So any of A, B, C, D are possible in scenarios outlined above. So this is just checking if you've been paying attention through the previous parts of the question, where it turns out that anyone could have been implicated. You could have been the culprit in one of the previous parts of the question. Alice says, I know the colour of my hat. I know the colour of my hat. So how could that happen? And I think key is that we could think about, I guess there's 8 possible cases, 8 cases of what the hats are. There's like red, red, blue, red, red, red. Or hang on, no, there's actually only 7 cases because blue, blue, blue is banned. So we get to go through thinking about all the 7 cases, but perhaps there's a better way to phrase it. Perhaps someone in chat can come up with one kind of succinct explanation. We need to explain our answer as well. If Alice can see a red hat and a blue hat, then Alice won't be able to tell what colour Alice's hat is. If Alice can see 2 red hats, then Alice won't know what colour Alice's hat are. Alice only knows when if both hats in front of Alice are blue. The way I read this, I was thinking about the link to the previous part of the question. And the previous part of the question is kind of the opposite, right? Previously, Alice said that Alice knew the colour of Alice's hat, right? That was part 1, wasn't it? Yeah. Now Alice says, I don't know the colour of my hat. So it's very tempting to say, well, that's the opposite. So Alice's hat colour must be the opposite. Must be blue. But that's not actually true. The opposite, in the opposite case, there's lots of possibilities. Remember, we had in part 1, we had the case Alice must be able. If Alice can see two blue hats, Alice can deduce that Alice's hat colour. But in all the other cases, Alice can't deduce Alice's hat colour. So this first statement, I don't know the colour of my hat, means that there's at least one red hat on Bob and or Charlie. Okay, if they're both blue, then Alice would be able to deduce that. And Bob hears that, I suppose. Bob hears Alice say, "I don't know." So Bob knows that Alice doesn't know. Okay, so there's at least one red hat on Bob or Charlie from the first thing. So Bob has this information. Alice says that. Bob now then says, "I don't know the colour of my hat," which seems a bit weird because if Charlie's hat was blue, then if Charlie's hat was blue or were blue. Grammar? Any grammar experts in chat? Is that were? If Charlie's hat were blue, Bob would know that Bob's hat is red. But Bob doesn't know. So Charlie's hat must be red. Yes. Cypher's put A knows. So yeah, I think the key into this problem is going to be, how has Alice worked out what Alice's hat colour was? I think the only way this happens is if Alice can see matching hats. There's sort of four possibilities for what Alice could see in general, right? Alice could see red, or Alice can see red-blue, or Alice can see blue-red, or Alice can see blue-blue. Those are the four possibilities. And in a couple of those cases, if Alice can see a red hat and a blue hat, then her hat could be either colour because it meets all of the conditions that their father's given them. But it sounds like Alice can see matching hats. Okay, Bob says mine is red. We don't actually need to understand Bob's reasoning. We don't need to understand Bob's reasoning here because Bob's an expert logician, so we can rely on Bob. But I think it's safe to say that Bob must have seen a red hat. See a red hat. So Bob knows they're matching, must see a red hat, knows the matching. I'm saying we don't actually need to understand Bob's reasoning. We can just take it as read that Bob has a red hat. And then Charlie's hat matches Bob's. So Charlie's must be red as well. So it must go blue, red, red. Nice. Some good stuff here. This is kind of the opposite scenario to the previous one. Alice has said, I don't know the colour of my hat. So it must be the case that Bob and Charlie don't match. I think that's true. Let's check what people are saying in chat. Yep. I think that's right. Bob and Charlie must be different colour hats. Bob says hat is red, and they've got different colours hats. So Charlie is blue. I think people's arguments that I've seen in chat are slightly more nuanced than this. I'm kind of taking a shortcut. I'm not quite sure if people in chat are on board with this or not, right? That I know that the hats don't match. So now I'm not going to think about what Bob's thought process was. Bob's an expert logician and is definitely correct. So Bob says his hat is red. I believe Bob. So Charlie's hat must be blue as a result. And you can go through and think about how Bob reached that conclusion. Bob, I guess, must have seen a blue hat to conclude that Bob's hat was red. But because Bob's an expert logician, we can just use that information. I'm not really sure if people are up for that. Two adjacent. Oh, there's a good way in. Two adjacent people have red hats, so Bob definitely has a red hat. Let's do that first. If two adjacent people have red hats, Bob definitely has a red hat, and everyone knows this. Not just Alice, who can see the hat, but also Alice and Charlie also know this fact straight away. Okay. If C is blue, okay, here's an argument. So the one I've highlighted says there are some options of what might be happening. It might be red, red, red. It might be red, red, blue. It might be blue, red, red, or it might be. Those are only the only three options of what it might be. Check those three cases. So check those cases against what their statements are. I quite like that as well. Okay. And people are coming in. So Alice says, I don't know the colour of my hat. So it can't be the case. Charlie can't be blue. Because Charlie can't be blue, because if Charlie was blue, then Alice would know that she was one of the red hats. So Charlie must be red. Okay, and actually Alice, I suppose, could be blue or could be red. So it's one of these two. Charlie writes numbers on Alice and Bob's foreheads and tells them each of your numbers is at least 1. The difference between the numbers is 1. Alice says, I know my number, which seems pretty surprising. And we're going to explain why Alice's number... yeah, Alice and Bob we're going to say why Alice's number must be 2. And it's because Bob's number must be 1. Bob's number must be 1. If it's anything else, then I've realised this looks vaguely menacing. For the people watching the YouTube video, this was supposed to be a pen when I drew it for drawing the numbers on the foreheads. Goodness me, that's a terrible drawing. Sorry. If it's anything else, then Alice wouldn't know. Alice wouldn't know if 1 more or 1 less. Crucial point here, for the rest of the question, I think there's 2 more parts of the question. For the rest of the question, the numbers are going to be between 1 and 10. So the previous conclusion that we just had doesn't apply to parts 2 and 3. In part 1, the numbers could be anything. In parts 2 and 3, the numbers are between 1 and 10. Alice's number is a prime number, and then we've got a little reminder of what a prime number is. So let's do cases. So cases. Something like Alice could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because we know Alice's number is one of these. But actually, most of these numbers are not prime, right? 4, 6, 8, 9 is not prime, 10 is not prime. So Alice is going to be one of these, 2, 3, 5, or 7. What have we got? We've got some talking now. Alice's number is a prime. So just by listening along to what Charlie said, we've worked out that Alice is one of 2, 3, 5, or 7. Okay. Alice says, I don't know my number. What does that mean? So what does this tell us? I don't know my number. So there's quite a few cases here, right? If Alice sees the number 1, then she would know her number was 2. So it can't really be that. If Alice sees the number 2, then she would know that her number is 3, because the only one of her possibilities that's 1 away from 2 is the possibility of 3. If Alice sees the number 3, then she would know it's number 2. If she sees 4, well, that would make sense, that she wouldn't know if it was 3 or 5. So maybe Alice sees 4. Yeah, it's going to be adjacent to 2 prime numbers. Brilliant. Okay. If Alice sees 5, then, well, she knows that that's impossible, so she can't see 5 because none of her cases are in there. If she sees 6, then she doesn't know if her prime is 5 or 7. If she sees 7, okay, could be well, that's actually impossible. If she sees 8, she'd be able to deduce it was 7. Okay, so these are the possibilities. Now, maybe Alice sees 4 or 6. Bob hears this and understands it and knows that Alice sees 4 or 6. I suppose they speak the same language as well. Whatever. Bob says, I don't know my number. I really feel like Bob's let the team down here. Bob had so much information. Bob knew that his number was either a 4 or a 6, but he can't tell. Like, really, Bob? You can't tell. We told you it was 4 or 6. You can see Alice's number, and Bob still hasn't worked out what Bob's number is. And the only way this can happen must be the case that Alice has 5, because that's the only way. That's the only way for Bob to still not know. I really can't stress how much work Alice did here, and how much Alice narrowed down the possibilities to just basically telling Bob you've got a 4 or a 6 written on your head, and Bob looks blankly back at Alice and still doesn't know what number Bob's got on his head. And the only way Bob can still be confused with all of this information is for Alice to have a 5. So, okay, Alice tells us that Alice doesn't know Alice's number, and asks if it's a square number, and Charlie doesn't answer. Charlie says, if I told you that, you would know your number. And there's actually 2 possibilities there. It could be the case, either Alice has a square number, and knowing this can work out which, or Alice doesn't have a square number. And knowing this, she can work out which. Why do I bother writing if my handwriting is going to be that bad? Okay. So, what have we got? So there's actually 2 possibilities. First time I tried this question, I thought Charlie was like heavily implying that Alice had a square number, but that's not actually what Charlie says. So let's think about some cases. Maybe Alice has a number like maybe Alice has, well, okay, so there's 10 possibilities. Alice could have 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. But if Alice has 1, then all this stuff about square numbers is nonsense. Because if Alice has 1, then Bob should definitely be able to know. Bob should know that B is 2. If Bob sees Alice has got 1 written on her head, Bob must know that Bob is 2, no matter what all this square number stuff is. And in this case, Bob would know. Okay, so these 2 cases are kind of not really interesting. Because if Alice had a 1 or a 10, then Bob would work it out. Good, cool. Someone said that in chat, which means I'm on the right lines. Good. Okay. Okay. Alice can see Bob's number. Yeah, Alice can see Bob's number. Knows hers is 1 more or 1 less. And the information from Charlie, telling Alice whether her number was square or not, would tell Alice which one of those it was. Okay, so there are 2 possibilities from Alice's point of view. Either Bob plus 1, or Bob minus 1. And it kind of must be the case that one of those is square and one of them is not square. I suppose Charlie's saying, good question. Yeah, if I told you that, it would give the game away. Because when one of your choices, one of your options that it could possibly be is square and the other one's not. Okay, so it must be the case that 1 more than Bob's number and 1 less than Bob's number, one of those is square and one of them is not square. Okay, 1 is square, 1 is not. Okay, so B must be 3 or 5 or 8, I think, because those are the numbers on one side of a square. Or 2? 2, or 2, or 2. B could be 2 or 3 or 5 or 8. Okay. B could be 2 or 3 or 5 or 8, because those are the numbers where Alice knows that she's on one side. One of those is a square, one of them's not. Try asking Charlie whether it's a square or not. Clever. Charlie says, that would give the game away. Alice would know. Okay. Right, so Bob must be 2, 3, 5 or 8. I think I saw those in chat or something as well. Okay. Bob then says, I still don't know my number, which is classic Bob. So Bob has all this information. He's been listening, I assume, and has heard that there's 2, 3, seen 2, 3, knows that his number's 2, 3, 5 or 8, and has the additional information. Bob can see Alice's number, but somehow it's the case that Bob still has at least 2 possibilities. You know, Bob knows that Bob is Alice plus 1 or Alice minus 1. Bob is still confused. I think the only way that can happen is if Alice has the number 4, because in all the other cases, if Alice has 1, Bob will know it's 2. If Alice has 2, Bob will know it's 3. If Alice has 6, Bob would know it's 5. If Alice has 7 or 9, Bob would know that Bob's number is 8. So Alice must have 4. I got there in the end. Whew.